Chariklo is a distant object which orbits in the outer solar system, between Saturn and Uranus. In 2013, Chariklo passed in front of a background star. This is an event called an occultation, and astronomers monitored the brightness of the star over time during the event. Plotting the brightness of the star with respect to time revealed the shape of Chariklo, revealing an ellipsoid shape and a ring system. At the time of this discovery, Chariklo was the only minor planet known to have a ring system. Before then, the only objects known to have rings were the gas giants and ice giants. As of 2025 though, we now know about 4 of such minor planets with rings. With a mean diameter of about 250 kilometers, it is also the smallest object known to have rings in the solar system. This occultation actually revealed that Chariklo's ring system consists of not just a single ring, but 2. The inner and outer rings are named C1R and C2R respectively. C1R is the brighter and closer ring, with an orbital radius of 386 kilometers and has a width of anywhere between 4.8 and 9.1 kilometers. In contrast, C2R is the slightly more distant ring, with a radius of about 400 kilometers. It is a much more faint and thin ring, with width anywhere between 100 meters and 1 kilometer. Chariklo's rings were notable because at the time of its discovery, scientists didn't believe that such a small object as Chariklo had enough mass to sustain rings. Computer models suggest that these rings should disperse over the course of a few million years, which is only 0.1% of the lifetime of the solar system. So there are 2 possibilities about this ring system. The first is simply that it formed very recently by some event around Chariklo. The second is that there actually exists at least one undiscovered moon in between the gap of C1R and C2R, balancing out the forces and keeping the rings intact. These are called shepherd moons, and all the giant planets are known to have them, so it's possible that Chariklo has some too. However, these moons, if they exist, would need to be discovered by some method other than direct imaging, since no telescope has been able to resolve Chariklo's rings. Chariklo has an orbital period of 63 Earth years, and is in a 4:3 orbital resonance with planet Uranus. This means that for every 4 revolutions Chariklo makes around the Sun, Uranus makes 3. It's part of a family of objects that orbit in this region called the Centaurs. Centaurs are believed to originate from the Kuiper Belt. If an object is disturbed or tugged in just the right way, it gets stuck in the Centaur region. Astronomical simulations of this orbit suggest that it was injected into the Centaur region from the Kuiper Belt in the past 20 million years, which is very recent on the solar system's timescale. In 2022, the James Webb Space Telescope used its near-infrared spectrograph, also known as NIRSpec, to analyze the spectrum of light Chariklo reflected from the Sun. The results strongly indicated that Chariklo has an abundance of water ice on its surface. Chariklo is not known to exhibit cometary activity though, because it's too far out from the Sun. Its perihelion is 13 AU, during which its temperature can be estimated to be about 75 Kelvin. In addition to all of this water, Chariklo's surface is known to be dark, with a reddish color to it. Additional spectrographic data explains this reddish color as the presence of tholins, which are a family of organic solids formed by the irradiance of carbon compounds. Tholins are very common in the outer solar system, around the moons of the giants and on dwarf planets. There are currently plans by NASA to explore Chariklo, namely the Camilla spacecraft, which is part of NASA's larger New Frontiers program. Its goal would be to launch in September 2026 and fly by Chariklo in January 2039 after several gravity assists. And we could get high-resolution data from this object. Camilla would also have a tungsten impactor to smash into the Centaur. As of October 2025 though, the mission is in concept phase, and further development depends on whether or not NASA selects it. Chiron is another Centaur orbiting between Saturn and Uranus. It is similar in size to Chariklo, albeit slightly smaller, with a mean diameter anywhere between 162 and 230 kilometers across. It was discovered in 1977 by the Palomar Observatory in California, USA. Its discovery is actually what prompted the creation of Centaurs as a category of minor planets, being the second object of its kind after 944 Hidalgo, which was discovered in 1920. Astronomers had observed several occultation events of Chiron, occurring in 1993, 1994, 2011, 2018, and 2022. Initially, they interpreted this data as being caused by Chiron's cometary activity, but it wasn't until 2015 that the presence of a ring system was proposed. Recent observations have been published, further analyzing the behavior of this ring system, suggesting that Chiron's rings may not even be well defined. Instead of being a stable entity surrounding the planet, the rings appear to evolve and morph. It is currently known to have 3 rings, but it may not even make sense to count how many rings there are with Chiron. Chiron has an orbital period of about 51 Earth years, and its perihelion brings it within 9 AU of the Sun. Like most Centaurs, it has a lot of water ice. Interestingly, at this distance, Chiron starts to show cometary activity. Its coma is not composed of water ice because it's still too cold for that to sublimate. However, several volatile gases have been observed in its coma, such as carbon monoxide, carbon dioxide, ethane, propane, and acetylene. Because of this activity, Chiron is also classified as a comet, making it the only known comet to have rings. By nature, the orbits of Centaurs are unstable, and computer simulations suggest that Chiron will become a short-period comet in the next million years. We now move away from the Centaurs and explore dwarf planets. Haumea is perhaps the most well-studied minor planet which has rings, owing to its status as a readily observable dwarf planet. Haumea was discovered in 2004, and the single ring it is known to have was not discovered until an occultation event in 2017. At the time, it was the only trans-Neptunian object known to have a ring system. The ring's radius is about 2,300 kilometers, and it is about 70 kilometers wide. Haumea is classified as a dwarf planet and has a diameter of around 1,740 kilometers. This makes it the third largest trans-Neptunian object known, after Eris and Pluto. Trans-Neptunian objects are just the bodies that orbit at a greater average distance than Neptune. Haumea orbits at an average distance of around 43 AU and takes 284 Earth years to complete an orbit. This is extremely far away. It takes about 6 hours for light from the Sun to reach the surface of Haumea. Given its distance from the Sun, this light is very faint. The intensity of sunlight received on the surface of Haumea is only 0.04% of that on Earth. Noon on Haumea would only appear as bright as twilight on Earth before sunrise or after sunset. Owing to this faint sunlight, Haumea is among the coldest objects in the entire solar system, with an estimated surface temperature of under 50 Kelvin. Similar to the Centaurs, Haumea's surface composition is mostly water ice, and spectroscopic observations reveal the presence of tholins on its surface. What also stands out about Haumea is its extremely oblong shape, almost flattened like a pancake. This is because of its very quick rotation period of just 3.9 hours, and the rotational forces at play have caused this oblong shape. This actually occurs with every object that rotates, including Earth. The Earth is not a sphere, but rather an oblate spheroid. The effect is subtle with Earth, but we see an extreme example with Haumea. There is a family of objects that have very similar orbital characteristics and composition as Haumea. This is not a coincidence. In 2007, astronomers announced the discovery of the Haumea family. It is a collisional family, meaning that all of its members are thought to have comprised a larger object billions of years ago. A collision with another object then shattered the Haumea progenitor into the highly dispersed fragments that we can see today. This collision, by the way, is theorized to be the reason why Haumea spins so quickly. Considered to be part of the Haumean family are its two moons, Hiaka and Namaka, both discovered in 2005. Hiaka is the outer larger moon, being 310 kilometers in diameter. Its orbit around Haumea is very circular, and it completes an orbit in 49 days. The inner, smaller moon is Namaka, and this one is a bit more unusual. Its orbit is very elliptical compared to Hiaka's, and it's also relatively inclined, meaning that both moons orbit on different planes. With both of these moons being made of mostly water ice, and a very similar composition as Haumea, these two moons are believed to be fragments of Haumea itself. The latest known ringed minor planet is Quaoar, discovered in 2002 at the Palomar Observatory. Quaoar, like Haumea, is a dwarf planet and a trans-Neptunian object with a ring system. The discovery of Quaoar's rings was announced in 2023 following an occultation event that was seen by the Gemini North Observatory. Quaoar is known to have an inner and outer ring, named Q2R and Q1R respectively. Q2R is the fainter ring and has a radius of 2,500 kilometers and a width of 10 kilometers. It is otherwise unremarkable, being stable and uniform. The more interesting ring is Q1R, the outer larger and brighter ring. Q1R is irregular. Its radius is about 4,050 kilometers, but its width varies drastically, ranging from 5 to 300 kilometers. Because of these perturbations, there may be undiscovered moons orbiting within Q1R. This would be similar to what we see with Saturn's F rings with its shepherd moons. Quaoar itself is around 1,110 kilometers across and makes a rotation on its axis in just under 18 hours. Its average distance from the Sun is similar to that of Haumea, at 43 AU. Unlike Haumea though, its orbit is very circular, so it's not taken as far away from the Sun as Haumea. Its orbital period is about 289 Earth years. As with most objects with this big of an orbit, Quaoar is an extremely cold world, with an estimated temperature of 44 Kelvin. Its spectrum suggests it has a red color like Chariklo, suggesting a strong presence of organic compounds and tholins. Observations by the James Webb Space Telescope in 2022 revealed the presence of solid CO2, carbon compounds, methane, and ethane ice. It is also known to have large amounts of water ice. These large amounts of volatile compounds once led astronomers to believe that Quaoar may also be able to sustain a very tenuous atmosphere made up of these organic compounds, but this was ruled out after a series of occultations showed no meaningful results. Quaoar also has one confirmed moon, called Quaoar. It's 170 kilometers in diameter and orbits at a distance of 13,000 kilometers. It has a very circular orbit and likely formed around Quaoar very soon after the formation of the solar system. There may be an opportunity to explore Quaoar in the future. The main proposal is a NASA spacecraft called the Interstellar Probe, which would launch in the window between 2036 and 2041, and use Jupiter as a gravity assist to reach the outer solar system. Although its main goal will be to study the Sun's heliosphere in interstellar space, it may have the opportunity to fly by previously unexplored dwarf planets such as Orcus or Quaoar. Like Camilla though, this mission is still in the concept phase, and further development is not guaranteed.